Welcome back, friends, to Unit 3D of this factorization series. Now we are answering question 3. Question 3 says we should look for the value of alpha raised to the power of 4 plus beta raised to the power of 4. Sorry, in terms of A, B, and C. Okay, but you must first get every bit of this value conformed to alpha plus beta and alpha beta before you can make this substitution. Okay, now let's go on, and we're going to be using 3 approaches in this video, in this lesson. The first approach is by the use of the binomial expansion of this value. Okay, the use of the binomial expansion of this value. The next one is making an expansion of alpha squared plus beta squared, everything squared, and alpha raised to the power of 3 plus beta raised to the power of 3 multiplying alpha plus beta. Of course, by the time you're done with the expansion, you're going to have alpha raised to the power of 4 plus beta raised to the power of 4 as your first and your last term respectively. Yes, after doing all this expansion, you're going to have alpha raised to the power of 4 plus beta raised to the power of 4 as your first and your last term respectively. So let's move on, and we are starting with this approach, alpha plus beta all raised to the power of 4 using the binomial system. Now going back to our Pascal's triangle, remember we're done using the binomial system where n equals to 3. So we continue with when n equals to 4. Okay, that's the new work we're doing. And from there we will be able to make use of these values. 1, 4, 6, 4, and 1. Okay, so let's pick up this bar and let's go to our working page to go and implement what we have to do. So coming up with the bar now, I'm having 1, first term which is alpha, and the second term which is beta. Okay, the first term which is alpha is going to be raised to the power of 4, the highest power. Then beta is going to be raised to the power of 0. The second term is 4. The second coefficient is 4. Then alpha being the first term here will be raised to the power of 3, and beta will be raised to the power of 1. 6 is the next coefficient. Alpha is raised to the power of 2, and beta is raised to the power of 2. Remember, the power of alpha decreases and the power of beta increases. 4, 3, 2. And here is 0, 1, 2. Okay. One increases, the other decreases. The power of alpha decreases, the power of beta increases. The next coefficient is this 4. Then alpha is out, raised to the power of 1. Beta is out, raised to the power of 1. 3, raised to the power of 3. The last coefficient is 1, alpha raised to the power of 0, and the beta raised to the power of 0. Beta raised to the power of what? Raised to the power of 4. Now let's get rid of every coefficient of 1, every power of 1, and every index of power of 0. So get rid of every index of power of 0 because they are 1. Every power of 1 is gone. Power of 1 is gone. Coefficient and the index with the power of 0 is also gone. So let's put addition sign here, addition sign here, addition sign here, and addition sign here. What do we have? We have what I have next in this next step. So bringing out alpha and beta, bringing them out here. I'm having the equality sign also out here. Then here is alpha plus beta raised to the power of 4 on this side. I just want to try and make an rearrangement. So look at all these values colored, bringing them to the other side of the equality sign. Okay, but they won't remain with the sign they came. They are going to change to negative. Okay, they are all going to change because they've all crossed the boundary of the equality sign. So with that done, I'm bringing out minus 4 alpha raised to the power of 3, beta raised to the power of 3. Here is another minus 4. The coefficient of minus 4. So let's bring them together for the sake of factorization. It will help us factorize easier and faster. That is the sake of bringing them together. So I'm having minus 6 alpha squared beta squared separately here. Then equality sign and everything on the right hand side. Okay. Now alpha plus beta raised to the power of 4. Now factorization. I'm not doing much thing on factorization here. I want you to tax yourself on this factorization. What is common? Minus 4 is common, of course. And an alpha and a beta is also common. This after raised to the power of 3 and this after raised to the power of 1. Of course, alpha is common to both. This is beta raised to the power of 1 and this beta raised to the power of 3. Of course, the beta is common to both. So, when we factorize, we have alpha squared plus beta squared in that factorized bracket. Then I'm having minus 6. I want to transform alpha squared, beta squared to make it conform to alpha, beta. So if I should do that, I'll be having alpha, beta in a bracket, then squared equals alpha raised to the power of 4 plus beta raised to the power of 4. So this is alpha plus beta raised to the power of 4. And I'm having minus 4 alpha, beta. Open that square bracket. This value, remember the very first work we did, will be giving me alpha plus beta squared minus 2 alpha beta. Please close the brackets. The very first work we did in Unit 3B, we got this. You shouldn't forget if you are following this series well. So this minus 6 alpha beta squared equals what you have on the right hand side. Have I been able to answer the question? Of course, yes. Every bit of term in my expansion already conforms to alpha, beta, and alpha plus beta. This is alpha plus beta, this is alpha beta, this is alpha plus beta, this is alpha beta, this is alpha plus beta. So I can easily substitute minus b over a and c over a appropriately. Let me see if I can make use of the second approach. Okay, so the second approach, I have to square this and see how it can help me get my value. So, squaring it, I have this as this value multiplied by itself. Okay? Now, when I do the expansion, what am I going to be having? I believe you understand what I did. The first term in this bracket, multiplying this white bracket. The second term in the same in this red bracket, multiplying this white bracket. That is a simple way of doing our expansion. Okay, so I believe you should follow me. Remember, I recommend a video on expansion. Please do check out. Just remove your brackets. You will have what I'm having down here. Alpha squared multiplied by alpha squared. That's alpha raised to the power of 4. Alpha squared multiplying beta squared. That's alpha squared beta squared. Beta squared multiplying alpha squared. That is alpha squared beta squared. Now, beta squared multiplying beta squared. That's beta raised to the power of 4. With that done, I'm having alpha raised to the power of 4. Here is alpha squared plus beta squared added to another alpha squared plus beta squared. That's going to be 2 alpha squared plus beta squared. Then plus alpha beta squared. I think I've not rushed you. I shouldn't. This alpha raised to the power of 4 plus beta raised to the power of 4, having them separate, then equality sign is coming out. What else? Alpha squared beta squared. You see the arrangement as they are moving. But these has crossed a boundary of equality sign, then it must change sign. The sign is changing to a negative power already. So with that done, alpha plus beta squared minus 2 alpha beta squared. How do I get that? Alpha squared plus beta squared. The very first question we did, we got this as a value. To have it conform to alpha plus beta and alpha beta. This is our answer. The very first question, question 1 in 3B. So everything, this red value in this red square bracket is this expressed in this golden bracket. Then I'm having minus 2 alpha beta minus 2 alpha squared beta squared. But I need to transform this to make them conform to alpha beta. Okay, so with the rule of indices, that is what it's going to change to. That is minus 2 alpha beta minus 2 alpha squared beta squared will give minus 2 alpha beta in a bracket, all squared. Then I have all I'm having in this right hand side of my equation. Have I been able to do what I am asked? Of course, yes. Every bit of my value is already conforming to alpha plus beta and alpha beta. That's it. So, I've used 2 approaches. And let's see, do they really work together? When I use the binomial expansion, I got this long value. When I use alpha squared plus beta squared, I got this value. So the question is, are they really the same thing? Are they equal? Because here I'm writing alpha raised to the power of 4 plus beta raised to the power of 4 equals this. And here I'm also writing alpha raised to the power of 4 plus beta raised to the power of 4 is equal to this. Okay? Now, if this is not necessary, I'm already suggesting to you next to drag your timeline to. I'm already displaying it on your screen. But I just wish you can wait and see if the two approaches I've used are actually the same thing or can hand me the same value. Okay? Just to rack your brain a bit, not to give you an unnecessary headache, but to show you that you can use different methods and you still get the same value. Okay, so let's quickly do that and let's see how it works out. So when I use the binomial expansion, I got this. For alpha raised to the power of 4 plus beta raised to the power of 4. And let's see, is there any further simplification I can do? Let me remove this square bracket and see how things are going to work out. So I'm having alpha raised to the power of alpha plus beta raised to the power of 4 minus 4 alpha beta multiplying that square bracket. What's it going to give me? I'm having two terms in this square bracket. So minus 4 alpha beta multiplying this fourth term. My first term is alpha plus beta all squared. So what's that going to give me? It's going to give me minus 4 alpha beta, then alpha plus beta all squared. That is, I'm using this minus 4 alpha beta to multiply this value. Then the same thing, I'm using this minus 4 alpha beta to multiply the second value. The second value here is minus 2 alpha beta. So when I multiply, I'm going to be having a positive 8 alpha beta multiplying alpha beta. So that's positive 8 alpha beta squared. Okay? And this is minus 6 alpha beta squared. Just like what I am having here. So let's look at it very well. Do I still have any values we can simplify? Alpha plus raised to the power of 4 and this minus 4 alpha beta multiplying alpha plus beta all squared. That's another term. And I'm having a third term here, plus 8 alpha beta all squared. And this minus is alpha beta all squared. So this plus 8 and this minus 6 are two values having the same terms. Of course, they are two values of the same terms. So I can add or subtract them. So I'm having minus 4 alpha beta, then alpha plus beta squared. So from plus 8 and minus 6 of this term, alpha beta squared, plus 8 alpha beta squared, minus 6 alpha beta squared, I can get plus 2 alpha beta squared. I know you agree with me. And I've not committed any crime. Okay? I've followed every rule that is well clear to you. Now let's look at the second approach and see if they are of the same value. So using the second approach, I got this. If you have been following and you have been putting things down, when I expanded this, I got this. So I want to confirm or check. You guys can probe the work. Is this value on your screen equal to this? Alpha plus beta squared minus 2 alpha beta all squared. Is it equal to this? If it is not equal, then I'm wrong. So you can check my error, okay? You can pause the video and just lay your pen on your paper and just check out. Expand this value, expand the square bracket, expand it and subtract this. Are you going to get this? Okay? Pause it and do something before we continue together. Alright, welcome back. I believe you have checked it and let's expand that square bracket. Expanding that square bracket will give me 2 of that square bracket. Of course, the value in the square bracket multiplied by the same value in the square bracket. That is the effect of this square. Then minus 2 alpha beta all squared. Now, let's do the expansion properly in this new box. I'm having 2 terms rather in each of the 2 square brackets. So I'm having an alpha plus beta all squared in this bracket, multiplying this whole bracket. So I'm having minus 2 alpha beta, which is the second term in this bracket, multiplying this white bracket again. I have not committed any offense. I just want to expand that square bracket to show that I've been getting the same answer. I'm doing this for you to show why I'm using different techniques that can easily help you not to cram anything. Sorry, I hate cramming. With all passion, I hate it. It's disappointing at times. So, when we expand alpha plus beta all squared. And I recommend a video on expansion. So the same principle I use there, the same principle is the same principle I'm using there, only that I'm dealing with more technical work here. So simplify this first bracket. What do I have? Removing the square bracket. This value multiplying this value. That's going to be that value raised to the power of 4. You understand that? Alpha plus beta all squared multiplying alpha plus beta all squared. That's alpha plus beta raised to the power of 4. So alpha plus beta raised to the power of 2, or raised to the power of 2 multiplying minus 2 alpha beta raised to the power of 2. Of course, it's going to give you minus 2 alpha beta raised to the power of 2. Minus alpha beta multiplying alpha plus beta squared, and that's going to be alpha plus beta squared. So minus 2 alpha beta minus 2 alpha beta, that's going to be plus 4 alpha beta all squared. Sorry, why positive? A negative is multiplying a negative to give a positive. 2 is multiplying 2 to give 4. Alpha beta is multiplying alpha beta to give alpha beta squared. I have not committed any crime. Or if there is still anything you don't understand, please put it in the comment section. That's what I'm here. I'm just telling you I've not committed any crime. I've been using the basis of expansion. So let's see. Can we simplify this? Minus 2 of this value and minus 2 of the same value, that can give me minus 4 of the value. Okay? Then next I'm having plus 4 of alpha beta all squared. Okay? This is a term, this is another term, this is another term, and this is another term. But 2 of the terms, the middle terms, can be added together or subtracted. So minus 2 of this value minus 2 of the same value, the black terms. That's why I'm having minus 4 of the value. This last time is not the same thing with them. It's not the same thing. So, looking at my work, have I been able to expand what I want to expand? I think yes, I've been able to expand this, just this. Okay, that's the value here. So, let me get rid of that bar and let me continue with my work. I've expanded this 2 square brackets. The next thing is bringing down this white value. Okay, minus 2 alpha and beta all squared. So, having alpha plus beta raised to the power of 4, all raised to the power of 4 minus alpha plus beta all squared. So this is plus 4 of this value, and this is minus 2 of the same value. Plus 4 alpha beta squared minus 2 alpha beta squared. That's plus 2 alpha beta squared. Okay? So look at this. And this value. Are they the same thing? Please look well. Or check well. I've just tried to prove that the 2 approaches can earn you the same value. Don't think it's hard. Just spend some few hours with it. Do it 1, 2, 3, 4, 5 times. They are not difficult. It will soon become your friends. And of course, math is your friend, is not your enemy. So let's look at the third approach and let's see how it works out. So the third approach is the power of 3 multiplying the power of 1 will give you the power of 4. Okay? The power of 3 here also multiplying the power of 1 will give you the power of 4. And that's the essence of using this approach. So I'm having this and this already, which is my goal. I bring them out already. And these 2 terms left here, these and these are already out here. They have crossed this multiplication, this equality sign. So the sign with them should change. Okay, so I've changed the sign with them. It's from positive they are having to the negative they have to have. So this value I'm having here. So let me see how I can use factorization again here. Please pay attention, factorization. So with my factorization, I got this. And I want you to do that yourself and know how I got it. I'm not going to be giving you everything. So, I have what I have on the right hand side. So, next, this alpha raised to the power of 3 plus beta raised to the power of 3 hence me this value. We've earlier worked on it. Our question 2, we got this. And that's just 2 terms. I'm seeing everything here as 2 terms. Then multiplying the second square bracket in gold. Alpha plus beta. Okay? So, it's minus alpha beta, and this value the very first work we did. This is in 3C. This one is in 3C. We got this answer in 3C. But this one now, we got it in 3B earlier. So, and we got it as this value. The very first work we did. So, the answer on the right hand side of the equation. So, don't be confused. This answer, we have gotten it already. To be conformed to alpha plus beta and alpha beta. We got it as this, the question 2. This is question 1. We got it to be this. Okay? So I'm just trying to fix them here. I don't need to change this because it's already in the pattern I want. This is alpha plus beta and this is alpha beta. So already in the pattern I want. So this is alpha plus beta raised to the power of 3 multiplying this. Okay? I want to remove the 2 square brackets. So this first term here, multiplying this, that's going to be what? Raised to the power of 4 of this value. So this second term, minus 3, blah, 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 in this white color, multiplying this, will be giving me minus 3 alpha beta, but now squared, because this value will be multiplying this value, and it's going to be giving me a square. I'm done with these 2 square brackets. I'm done. So I have them simplified already. So this is now minus alpha beta multiplying the square brackets. So I'm going to be having alpha beta open bracket alpha plus beta all squared. Now this minus alpha beta multiplying minus 2 alpha beta. That's going to be a positive 2 alpha beta square. Of course, negative multiplying negative will give a positive sign. Is 2, and this is alpha beta multiplying alpha beta. That's alpha beta squared equals alpha raised to the power of 4 plus beta raised to the power of 4. So here is alpha plus beta raised to the power of 4. Now this minus 3 of this value, and I think this is minus 1 of the same value. This is alpha beta open bracket alpha plus beta all squared. This is also alpha beta open bracket alpha plus beta all squared. So this is minus 3 of the value, and this is minus 1 of the same value. Simplify, please. That's minus 4 of that value. Minus 3 of that value, minus 1 of the same value, that's minus 4 of the value. Then, plus 2 alpha beta squared equals to what I'm having on the right hand side, the value I'm looking for. Please, the 3 values I've gotten using these 3 approaches, are they not the same thing? Sorry for boring you with my too much analysis, but it's to the end that I want you to know that using different approaches can help you get definitely what you need. Definitely can help you guys get what you need without cramming in an examination hall. You don't need to cram, you don't need to cram at worst. Do your binomial expansion at worst. I'm doing this because of some smart guys outside there thinking that they may probe me, and it's good you probe, okay? It's good you probe. So pick your pen and just do these things I've done. Finally, I have this value expressed as minus b raised to the power of 4 and minus 4c over a minus b over a squared and blah 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 blah. And I can have it simply as this negative will go because of this power of 4. This negative will also go because of this power of 2, but we're already having an extra negative here. So that's why the negative here is coming out. And I'm having 4b squared over a raised to the power of 3. There is a square here because of this square. There is a here, so that's a raised to the power of 3. There is b squared here, there is c here, so that's b squared over c. Okay? I believe that simplification should not be too hard for you. Okay? It shouldn't be too hard for you. So this is an attempt of making it a single fraction. Then you have this. That is if you want a single fraction. And that's my answer. So the last one is this question. Alpha raised to the power of 5 plus beta raised to the power of 5. 3 different approaches. This binomial expansion. This alpha raised to the power of 1 multiplying alpha raised to the power of 4. This beta raised to the power of 1 multiplying beta raised to the power of 4. Of course I will get this. Now this is alpha squared multiplying alpha raised to the power of 3, I will get alpha raised to the power of 5. Beta squared multiplying beta raised to the power of 3, I will get beta raised to the power of 5. With that attempt, I was able to get this value. zooming in and out on your screen in golden color. Okay, now I'm showing you this not for you to accept it, I'm showing you for you to be able to probe. And I'll be very glad for somebody to comment in the comment section or give me a call that this value is wrong. Whoa, I'll be very happy to hear that. Oh, so I will know that some people are actually following this video. Okay, so I'm expecting you to tell me this value is wrong. Okay, and you have a price for that. You can just tell me this price is wrong and probe it. Okay, so the problem and probe it. Just put your pen on your paper and make an attempt. Use this first method, binomial expansion. I actually use the third approach and I got this. Okay, so it's very simple, it's not hard, you can also get it the same way I got it there. That's the joy in mathematics. Okay, so with that done, imagine you are to simplify it further and do your proper substitution. You know that your alpha plus beta is always minus b over a, alpha beta is always c over a, alpha plus beta is always minus b over a, alpha beta is always c over a, and alpha plus beta is always minus b over a. Imagine you have a quadratic equation where you need to supply all these values. Your work is already simplified for you and you are good to go. I believe I've not confused you. Then we'll meet in the last part of this unit 3. We have had a very long unit 3. Do remember to subscribe, hit the like button, and see in the last part, which is the inequality part.